This is 2009 AB number 4. Let's do it. Alright. Let R be the region in the first quadrant enclosed by the graphs of y equals 2x and y equals x squared, as shown in the figure above. Find the area of R. So the area of a region like this is the integral from 0 to 2. I'm going like this because I'm imagining that like Riemann sum, right? The area as we go through this way. Of the top one, that's top minus the bottom one. This is a no calculator problem, but that's pretty easy antiderivative to find. That'd be x squared minus x cubed over 3 from 0 to 2. Plugging the 2 in here, that's 4 minus 8/3, and then minus 0 when I plug that in there. And you do not have to simplify. You can leave that. That's a purely numeric answer, so you don't have to do any more work. But if you did, that's 12/3 minus 8, that'd be 4/3. So whatever you like there, you can leave it like that. The region R is the base of a solid. For this solid, at each x, the cross-section perpendicular to the x-axis, so we're slicing this way. That's good news. It means we don't have to do any tweaking of those. Has area of this. So they're telling us what the area is of each cross-section, right? So to do that, I need to integrate across 0 to 2, and then each one of those slices, as we slice through here, I don't know what they look like, they're just telling me what the area is. So something like this, the area of each slice is sine of pi over 2x. And that's because they told us it is. So when you're doing the cross sections, you just have to integrate across whatever the area is of the cross sections. Now this is, you got to be careful here. The antiderivative of cosine, of sine, sorry, is negative cosine. Because there is a multiple here, or a coefficient on the x, we're taking an antiderivative, so I need to divide by that, or multiply by its reciprocal. You could also, if you want to, you could write out a u substitution. You could say u is equal to pi over 2x. So du is equal to pi over 2 dx. Pi over 2 is just a number, of course. And then you would need a pi over 2 on the inside, and that means you would need a 2 over pi on the outside, and then sine u and all that. That's fine. But when you do this kind of game, when you're taking antiderivatives, if the only thing going on the inside is a multiple on the x, you just have to divide by that. That only works when you have x to the first power here. Any other higher powers than first power, you've got to do a u substitution. Alright, so let's see what we got here. I am going to factor this negative sign out to the front because I like to do that. So then I've got cosine of, that would be cosine of pi minus the cosine of 0. You don't have to factor that negative sign to the outside. I just prefer to do that. Because this is going to be a minus here anyway, I feel like that's a sign mistake waiting to happen there. So I got negative 2 over pi. You can't leave the answer like this. You do have to actually evaluate when you get to here. So the cosine of pi, think about the cosine function, that's negative 1 minus cosine of 0 is 1. You can leave it like that. But if you simplify it, you're going to get 4 over pi there. All right. I'm going to need a little extra paper here to finish this one. For part C. Another solid has the same base. For this solid, the cross sections are squares, right? But do not evaluate an integral expression for the volume of this solid. And they're perpendicular to the y-axis. So that means I'm slicing across this way. And if I'm perpendicular to the y-axis, that means it's got to be a dy integral, which means these things, I have to solve them for x. So this would be x equals 1/2 y, and this would be x equals the square root of y. Right, so each one of these cross sections, make a quick sketch of it here. Each one of these cross sections is, if you pull that out, it's going to be a square where this is like a side of the square. Now, if it's a dy problem, then instead of top minus bottom, I'm going to have to do right minus left. So this is like the outside edge of the square. That's the square root of y minus the inside edge is 1/2 y. That's what the side of the square is. So the area of each square is going to be square root of y minus 1/2 y squared. This thing squared. The important thing, the mistake I see most often is putting the square on each one of those instead of squaring the whole thing. And of course, you can't distribute exponents. That does not work because math. So the volume of the whole thing is the integral. Now, this is a dy problem, so it's going to go from 0 to 4. We're talking about y values here, right? So from 0 to 4 of the area of the squares, and that's it. If you wanted to review this, this is all the area stuff is in section 7.1. That's part A of this question, and then the volume stuff is in section 7.2.